Yeah, already. Thank you. And I will opening for this class today. Good morning, everyone, and our audience. To start this class today with Vidyavardhaka College of Engineering, I hope we have a good mood and for this event will run smoothly. I will introduce lecturer today from Vidyavardhaka College of Engineering, Professor Nithin Kumar as a assistant professor, Department of Computer Science with the topic Computational Entomology. Yeah, so everyone, now we will start class for. Thank you. Yeah, for Professor, you can start for this session.
Thank you, madam. Thank you. So good morning, one and all present. Good afternoon, one and all present here. Why? Because it's morning, still 10:30 in India. Okay, I don't know whether it's 11:30 in your country. Okay, so myself, Nithin Kumar, working as an assistant professor in Department of Computer Science, Vidyavardhaka College of Engineering. So today I'm here to give it's not possible to convey the whole concepts within this 1.5 hours. Just I'm going to provide an insight about a new branch by name Computational Entomology. Okay, so let's start with the presentation. So, madam, is my screen is visible?
Oh no, I don't see your PPT.
Okay. Is it visible now?
Yeah, is it first invisible?
Okay. The topic that I'm going to explain in today's session is on computational entomology. So before I start with this particular topic, the name itself suggests that. So here we are going to address the problems of a domain by name entomology by using computer science. Computation plus entomology, together we call it as computational entomology. So firstly, what is entomology? So entomology means it's a derived branch from zoology. So we are going to study only about insects, only about the insects and their biological background and the environmental related background and their interaction with the other organisms. That's what we call entomology. The persons who are going to work in this particular field are called entomologists. So completely entomology is a department that comes under zoology. So where it will be completely concentrated on study with respect to insects. Zoology means it deals with both vertebrates as well as non-vertebrates. Entomology means it's a derived branch that comes under zoology where we are going to learn, we are going to work only related to insects. Insects means we will come across two types of insects. One is harmful, other one is pollinators. So what's the advantage? Why you need this computational entomology branch? So this entomology branch, this entomology serves as a basis for development of biological and chemical pest control companies, pharmaceutical companies, food production companies, biological diversity, robotics, and etc. So how this entomology is related to this pharmaceuticals? For example, so even if you consider mosquito, that will also an insect. So yearly, close together people are dying because of various infections or various diseases that are transmitted through mosquitoes. So the pharmaceutical companies, they are going to analyze it. So which one is what's the cause and how to rectify it, and how chemical and biological pest control means how to rectify, how to reduce that mosquito or other harmful insects. So we have not only we have harmful insects that comes under entomology. So consider example, as I mentioned earlier, mosquito is an harmful insect. Similarly, we have honeybee. That's a pollinator. Okay, the study of insects is called entomology. Okay, so next, what's the importance of pollinators? Why? Because as I mentioned earlier, here we will come across two classes of insects. One is useful, other one is harmful. So which are useful one? Beetles, pollinators, honeybees are the different useful insects. So that will help in pollination and that will reduce the scarcity of our food. But there are harmful insects such as, I don't know how many of you know the name Bactrocera dorsalis. Bactrocera. The name is Bactrocera dorsalis. So even if you Google the term, you will come to know how harmful that particular insect is. Why? Because whatever the crop loss that's happening now, it's because of that particular class insect. It's going to damage worldwide crops, as well as, for example, not only Bactrocera dorsalis, Bactrocera cucurbit, like that we have a lot of insects that comes under class Diptera. And mosquito, that's also harmful insects. So then what's the importance of pollinators? Why we need to learn this computational entomology? So please remember one thing. So if you eat food 3 bites, means out of those 3 bites, 1 bite, for 1 bite, pollinators are responsible, directly responsible. That means overall 35% of food production, what we are getting right now, it's because of pollinators. So we have to conserve them. Why? Because they are in danger. The loss of pollinators can result, for example, so what we are reading, what we are eating, such as wheat, rice. So such thing for pollination of such cereals, we don't want any pollinators. It will happen over air. But for fruits, for various fruits that you are going to eat, for various vegetables that you are going to eat, for that pollinators are required. The cereals that we are going to eat, wheat, ragi, rice, etc., jowar. Okay, for that we don't want any pollinator present in 3 to 4 centimeter. But the thing, when you are going to eat, when we are eating fruits and vegetables, the pollinators are required. The loss of pollinators may decrease the food production ultimately. So extension of some plants. So globally, 90% of wild flowering plants species are dependent on pollination. So honeybees are responsible for $15 billion worth of crops in United States each year. So just this shows what's the importance of pollinators and why we need to conserve them. So recently in Forbes article in 2021, they have released a magazine stating that, so using artificial intelligence, IoT, cloud, and advanced computer science technologies, we can conserve, we can save the pollinators. Why? Because they are in stage of extinction. If that continues, so please remember here, I have used the term 35% of food production is completely dependent on pollinators. So that 35% will become zero. That means now only we are dying because lack of food. If the pollinators are nowhere present, means so whatever now we are eating, so we need to reduce that to 2 bites. Why? Because if you are eating 3 bites, means out of those 3 bites, 1 bite is completely because of pollinators. That's this slide shows why you need to conserve pollinators, why you need to work towards the computational entomology to save the pollinators are useful insects. So what is computational entomology? So please remember one thing. So either it may be machine learning or it may be data, artificial intelligence, natural language processing, whatever that you're going to learn, that particular domain will be derived from data mining. Data mining is the mother of machine learning, natural language processing, and artificial intelligence. Why? Because without data, without working with data, it's not possible to learn. It's not possible to make your system understand. So what is computational entomology? Computational entomology is once again, it's a derived branch that comes under data mining. So this can be divided into 2 sections. Okay, computational entomology can be divided into 2 sections. One is information collection system and information analysis system. information collection system and information analysis system. So why you need this computational entomology? What is computational entomology? So these are the two sections that comes under computational entomology, that is information collection system and information analysis system. So the major theme of this computational entomology is to recognize the harmful pests or harmful insects or the pollinators so that the person or the entomologist can take necessary actions. Why? Because we cannot bring entomologists to all fields and farms. So to check the availability of pollinators, whether they are present in actual count, whether there is a decrease in count, whether we need to do something. Why? Because those persons are, especially in our India, they are not readily available. There is a lack of scarcity of entomologists. So if we develop something that can be automated, so that based on that results, so if it's possible to take the action, then that will help our farmers in a huge manner. So that's why this branch has been emerged. And please remember one thing. So hardly you can find around 15 to 20 papers on this computational entomology. Why? Because it's just an emerging branch which has emerged from 2020. Hardly 20 to 25 papers, and specifically 4 to 5 persons from Germany and Greece are working on this. So as I mentioned earlier, the computational entomology is nothing but it's a derived branch from data mining, which helps to apply the computer science knowledge on entomology field to study about the insects. So that can be divided in two sections. Please, if you observe this diagram, where I have divided the computational entomology domain into two sections. So first section deals with the information collection, where we are going to gather the information about the insects, such as, so you can use camera sensor, or you can use cameras, you can use various variety of sensors such as ultrasonic sensor, IR sensor, whichever sensor, various sensors which can recognize the physical movement or physical characteristics of an insects. Such things can be embedded here along with the weather parameter sensors such as humidity, rainfall, and temperature. So such things are recorded and transferred to the information analysis sensors, machine learning, image processing, image capturing sensors, and wide variety of sensors which are required to measure the environmental parameters, and such thing will be transferred to the information analysis system. So information analysis system means we have data that has been sent from the information collection. So in analysis, we can apply any suitable algorithm that you know with respect to machine learning, deep learning, or natural language processing, or artificial intelligence, data mining, whichever the algorithm that is suitable for the data that I have collected, you can apply that particular algorithm and you can come to conclusion whether you need to use pesticides or whether you need to use some biological methods to improve the pollinators count, so that my farm or the agriculture field will be secure from the pests. Simply spraying pesticides, whenever you observe 2 to 3 pests, simply spraying the pesticides, it will not serve the purpose. Simply, it will adulterate that particular food. Obviously, if you spray pesticides and fungicides, means obviously you are killing some pests, harmful pests that's going to damage your crop. Along with that, so your crop will be contaminated. So such things can be avoided. So based on the information that you are going to gather using these various technologies or various methods, so based on the analysis, you can come to conclusion that when to apply the pesticide, when the pest or the harmful insects count is more, and when to increase, whether in my farm I have enough sufficient number of pollinators are present. So such actions can be taken. That's the role of computational entomology. Okay, so you can divide the computational entomology into two sections: information collection system and information analysis system. Information collection system, it's nothing but a working part, so which we are going to implement in the farm fields. So the data gathered from the information collection system will be analyzed using various algorithms that are present in data mining, machine learning, or whatever the data, in the which form of data that you have recorded from the collection system. So based on that form, So you can apply that suitable algorithm and you can come to conclusion whether I need to go with pesticide, whether I need to go with increasing the pollinators count by using some biological methods. Why? Because to kill the pest, we don't have any alternative method. We have to spray pesticides itself. But when, how much, where such things can be recorded by using this computational intelligence, by using this method. Okay. So next, so how to recognize, sir? How to recognize whether I need to go with pollinators increasing biological method or whether I need to go with pesticides. So please observe, as I mentioned in this slide, so any particular insect can be classified by using only 3 techniques. You can recognize or you can identify any particular insect by using these three methods. Which are those? One is based on the characteristic feature. Other one is based on the morphological feature. Other one is based on the environmental parameters. So what is the characteristic feature means? Characteristic feature means it's nothing but how that particular insect is going to behave, how it's going to fly, what the speed. So such things are called characters, means how it's going to behave. Such things can be recorded to identify which class of insect is that. That feature is called characteristic feature. The main attribute that we are going to consider in that characteristic feature is wing beat frequency. Wing beat frequency. So in next coming slides, I will show how to record that wing beat frequency to identify any particular insect. So next one is widely used method, that is nothing but morphological features. Morphological feature means based on, for example, I have captured an image of an insect. Based on the texture, shape, color, and size, I'm going to come to conclusion. I'm going to classify it by using various wide varieties of image processing techniques, and I'm going to classify whether a particular insect is a pollinator or it's a harmful pest. Next one, environmental parameters. There are some fungus or harmful fungicides such as downy mildew that appears in grapes. Grapefruit. Okay, so based on the being recognized, so whether temperature 28 degrees Celsius, humidity 80%, the rainfall is 8 centimeter, season is spring. Is it required to use some pesticides to avoid the downy mildew or not? By Udan-Markova model, so you can come to conclusion whether you have to go with the usage of pesticides or fungicides in that scenario. Like that, these are the 3 attributes or the 3 parameters which you can use for identification of any insects. One is characteristic feature, how it's going to behave, how it's going to fly, what's the wing beat frequency. Other one is morphological feature, how it looks, what's the texture, what's the color, what's the shape, what's the size. Next one is based on the environmental parameters. This environmental third one, the feature, is not applicable for all insects, only for selected insects which will grow in particular season, in particular suitable environmental parameter. Okay, so how these insects can be classified? So please remember one thing. So every individual plant, every individual plant which attracts pollinators or harmful insects by name methyl eugenia. Methyl, okay, that will attract the pollinators as well as harmful insects to particular plant. So such things can be used to attract for our setup that we are going to use and to classify it. Okay, so major years, the conclusion is, so the selection, the features that you can use to recognize whether it's a pest or whether it's a useful insect is based on characteristic, based on morphology, based on environmental parameters. So most widely used are characteristics and morphology. Okay, simple study. This is a simple study on characteristic feature. How it's going to recognize, please observe. Here I have 3 things present in my slide. One is Arduino, other one is microphone, okay, breadboard. Okay, so please observe, whenever the insect passes in front of the sound module or the microphone, it's going to record the sound produced by the insect. Why? Because just if you remember, so whenever a mosquito flies in front of your ear, you are going to listen the sound produced because of its wing. The sound is not produced by mouth. The sound will be produced by wing flaps. So such sound can be recognized and it can be analyzed, and you can come to conclusion that whether it's a mosquito or not. Such kind of study is called as a characteristic feature study. Just a simple setup. This one is a simple setup where you have Arduino board, breadboard, and sound module. So you may
Ini jaringan yang jelek atau gimana? I think Prof is finishing. Okay, but jaringan bagus. Ya, sama. Oke, bentar. Just a moment, please. Prof, I will change your position with co-host. Okay.
Okay, sir. Madam, sorry for the inconvenience.
Okay. Yeah.
So as I mentioned earlier, it's a sound setup. In front of sound setup, we will make the insect to pass in front of it. We will recognize the sound produced by the insect based on the flight, and we are going to classify based on the sound. Okay. So next one, please observe here. So here we have two tunnel-like structures. In between the two tunnel-like structures, we are passing a light that is nothing but LED, and we are going to make the insect pass in between this LED, so that we are going to record a fluctuation in a frequency. Okay, why? Because there is a one light emitting source, other one is photo transistor. It's going to record the fluctuations in that light. Okay, so based on the fluctuations recorded, we are going to classify which kind of insect is that one. Why? Because the flight frequency will vary from insect to insect. The wing frequency, for example, housefly will flap the wing. If it in the flight mode, when it's flying, it will flap the wing for 1 second. It will flap around 70 times. Similarly, for example, if you consider a mosquito, it will flap around 120 times. Likewise, the wing flaps will vary from insect to insect based on the size and shape. Okay. Second one is, once again, it's the same, such as what we have discussed. It's an electro microphone. It will be placed inside the setup. So to recognize the sound produced by the electronic in the form of hertz, gigahertz. Okay. So which are all the suitable sensors that we can use to recognize the character features? As I mentioned earlier, the character feature means it's nothing but sound as well as wing beat. So which are all the suitable sensors you can use? Optoelectric sensor, it's nothing but one sensor setup to light emit, other one sensor setup to detect the light. In between that, you will make the insect to pass in between that. So such setup is called as an optoelectric sensor, LED sensor, IR reflexive sensor, ultrasonic sensor, laser sensor, and microphone to detect the sound produced. These are the various sensors which can be used for the character feature selection, recognition. So technologies you have to use here is Fourier transform and signal processing. Why? Because whatever you're going to record by using these technologies, it will be in the form of waveforms. Why? Because you're going to record frequency of flight, you're going to record the sound produced. So such things will be in the form of waveforms. So such signals will be amplified and processed to get the actual digitized one, to get the actual digitized value. So these are the tools are the technologies that you have to use while working with the character feature recognition of an insect. So what are the downfalls of this character feature recognition? Just observe. So if you consider a wing beat, okay, so it will vary based on these three parameters. Geographical region. For example, I have grown in a very well-established rich family. So obviously I will be having very good food. Okay, I will be having very good food. So obviously my growth will be good. So if I am based on the genetics, if my parents are 6 feet height, obviously even I will be height. So morphology based on the muzzle weight. Why? Because these three things are independent. So how you're going to recognize the characteristics? Why? Because based on the muzzle weight, based on the size of the insect, the number of wing flaps will vary. Number of times it's going to flip the wings will vary. So it will depend on geographical region, genetics, and morphologies. These things are not in my control. So it will lead to error. Based on these three things, so it may cause the error. Okay, and even that data set is not available on this characteristic behavior analysis. Only you can find the data set on mosquito characteristic behavior analysis. Okay, it's not sufficient to train your deep learning or neural network or machine learning models. Okay, but the advantage with respect to this characteristic behavior analysis, as I mentioned earlier, hardly that particular microphone or light setup will cost around 100 rupees in India, 100, 200 rupees. Okay, so cost effective but consumes less power. But the classification or identification that is done by using this characteristic behavior is not serve the purpose. Why? Because it is completely dependent on geographical region. Why? Because the insect aerodynamics means how the insect is going to fly. It depends on geographical region, genetics, and morphology. Okay, such things are not in our control. Okay, whatever the output that you're going to record, the waveforms, frequency that you're going to record, it's a small thing. It's not suitable for your machine learning algorithms for analysis purpose. Okay, before analyzing, I need to set a threshold, right? For example, my frequency is 120. If the frequency is 120 means it's a mosquito. For that, you need to record the initial threshold for that where we are going to get the insects. Even if you get the insects, means we don't know how they are grown, in which geographical condition they have grown, and what's the genetics and what's the morphology. Okay, these are the downfalls that comes under characteristic behavior analysis. But coming to morphology, please observe. So morphology is nothing but is based on the physical parameters. Based on the physical appearance of the image, particular insects, you're going to perform the classification. So there are three types of classification that can be done by using morphological features. One is label-based sample classification. Label-based sample classification is, for example, for this particular insect, I'm going to give a label, that is Bactrocera. So whenever this particular insect is recognized, Bactrocera. Field-based classification, sample classification. So if you implement your device in the field, where you will come across wide variety of insects, such classification is called field-based classification. Multi-individual sample classification. So my device should be in such a way that even if I place this particular classification model, and if I place around 15 wide variety of insects, multi-individual samples, it should classify. These are the three ways to perform the classification using morphological features. So this is how you're going to place a camera sensor, an image sensor inside the trap or the device, so that it will recognize the insect which has entered that particular device and it will classify it. Okay, so you can increment the count for every individual insect entry. Okay, so you can increment the count. Okay, the sensors, the setup that is required for this morphological classification is image capturing sensor. So that with the Raspberry Pi camera and with minimum 5 megapixel image is required with focus. Okay, which are the technologies that you can use? Imagements, you can use any machine learning algorithms such as KNN, random forest, SVM, CNN architecture such as LeetNet, AlexNet, VGGene 16, 19, ResNet, like that. You can use any architecture. So digital image processing using MATLAB, transform-based learning. So you can use advanced technologies to classify the insect by using morphological features. But these technologies will not support the characteristic behavior. Why? Because the characteristic behavior, the data that we are going to acquire is very minimal. For that minimal data, it's not possible to apply this kind of algorithms. Oh, we can apply, but the error rate is high. Okay. So what are the advantages and disadvantages of this particular characteristic morphological feature analysis? So as I mentioned earlier, to detect and classify any flying insect, we will use only two features. One is characteristic, that's nothing but sound or wing beat. Second one is image, based on the size, texture, pattern. Okay, so what are the downfalls? What are the advantages of this particular morphological behavior analysis? One is cost is more compared to characteristics. As I mentioned earlier, in characteristics, you are going to use small sensors. It will cost 200. Here you use high dimensional camera, that it will be around 5,000 to 6,000 rupees in Indian currency. What are the advantages? That's the only one drawback with respect to this morphological feature. What are the advantages? So if you are doing this kind of detection, you can make use of cloud tools, cloud platform by using AutoML, and you can use very advanced tools such as TensorFlow. You can use various varieties of edge computing devices such as NVIDIA Jetson, Google Coral Accelerator. Like that, you can use wide varieties of advanced technologies, and the answers that you're going to get, the classification result, it's almost accurate. Almost 90% accurate compared to the morphological features. The accuracy that you can expect from the morphological feature will be around 50 to 60%. But the accuracy that you can expect from this particular characteristic behavior analysis is around 90 plus. Okay. So just here observe, I've applied some machine learning algorithms to classify. So the 5 classes of insects, one is Archerna, Diptera, Heteroptera, Hymenoptera, and Leptoptera. These are the 5 classes of insects that machine learning technique that I have applied is decision tree. So I have obtained around 82% accurate result. This is my confusion matrix. On 5 classes of insects, I have applied decision tree. So please observe, I'm not applying the decision tree on characteristic behavior, sound or wing beat. I'm applying it on image. So this is my classification result. The accuracy is around 83%. Okay. So similarly, I have applied fine Gaussian support vector machine. So this gives the accuracy of this particular thing this is the one machine learning technique. So where I got around 87% of accuracy in classification. Okay, just by using this simple SVM model, the accuracy is 87%. Just imagine, so if you apply characteristic behavior, the accuracy is around 50 to 55%. But if you apply it based on the image data set, morphological feature based one means the accuracy will be around 80 plus. Okay, so similarly, I have conducted a simple test. I don't know how many of you know about the teachable machine platform. So where you can develop a simple machine deep learning model without using any programming language, just give the samples and train the model and classify it. So here I have used 3 classes of insects. One is arena, it's nothing but spiders. Coleoptera, it's nothing but a harmful insects. And Diptera, it's nothing but Bactrocera dorsalis. Okay. So in first classification, what I'm doing here, I'm giving a sample by name arena. The classification accuracy is 94%. That device has the model that I have trained is classified. Just please observe here. You can look at the count. How many image insects sets I have given here? 18, 23, and 30. Just by using this many samples, the classification accuracy is 94%. Okay. So next, it has been classified that next Diptera 99%. Next, Coleoptera 100%. Just please observe the sample that I have given here is very less. Okay, very less. The platform that I'm using here is teachable machine. That is a teachable machine. So it works based on the transform learning. What is this transfer learning? Teachable machine is a web-based tool to create the machine learning models in the easiest, fastest manner. So what's the input that we are going to use for this teachable machine? Set of images with class label. Output will be classification of detected image. First step, give the different class labels for training data. Just I'm going to give the names of for the various class labels of present in training data. Then load the labels to the dictionary, provide the training images, and it will automatically format the image. And the image will be reformatted to square and return the output interface. So now you can load this particular model into your edge computing devices and you can classify it. It's a simple procedure. So the model name is model that we are going to use here is let's say by transform learn. Okay, this is a deep learning based architecture. Okay, so next even I have developed a simple convolution neural network model. So where I'm going to ask the user to enter the data set, train the data set and select it and classify. Just I have given another one example, sample by name Odenta. So just observe, this is how it classifies. The classification accuracy of this particular CNN model is 94%. It's a simple CNN model. I'm not applying any advanced architecture, just a simple CNN model. The classification accuracy is around 94%. Okay. So this is what totally I have applied around 1, 2, 3, 4, 5, 6 various techniques. So out of this 6 various techniques, the accuracy of CNN is more compared to all other which are present. So this concludes that the deep learning model will work fine compared to all other machine learning models that I've used in my study. So linear SVM, quadratic SVM, decision tree, cubic SVM, and fine Gaussian SVM. So all these models are machine learning models. CNN, this is the one and only one, which is based on deep learning. So the accuracy of this CNN is 94%. So compared to all other. And please remember one thing. So whenever you are going to use the machine learning model, you have to perform feature extraction. So I have used GLCM, gray level co-occurrence matrix. So similarly, you can use any other different models. Okay. Any other different models. So as per your feature set, which is required, but the feature extraction itself is going to be tedious. Okay. So, but in CNN, there is no need of providing any feature. Just you have to design the layers so that layers will automatically in turn record the features. Okay. So what else? So just now, is it clear? So just now I explained what is morphological feature, what is characteristic feature, and how to apply the machine learning methods, how to apply the mobile net. That's nothing but a teachable machine which is already available, and deep learning model, that is CNN. So these are the some works which I have done. So what are the application of this computational entomology? Why we need to apply machine learning or deep learning, and why we need to spend time? First one, development of insect pest model. What is that development of insect pest model? It's nothing but it's a simple thing. So for every individual harmful insect, you can develop a model in such a way that, for example, in month of March, in India, Bactrocera dorsalis count will be more. In month of November, there is no need of spraying any pesticide. Why? Because the harmful insects will be less. And especially you need to spray the pesticides in month of March. Like that, you can develop a model so that so it will serve, which will serve as a prerequisite for the farmers. So that instead of simply spraying the harmful pesticides and fungicides to that eatables, so they can spray based on that model. That's one advantage of this computational entomology. Okay, so and it will produce a huge data set that will work as that will help the entomologist so much. Why? Because the entomologists nowadays, they have to perform field monitoring. They have to visit a field and they have to check for the particular insect or the pollinator. So such things can be reduced by using this by using this technique. The manual field that you can record the density of wide variety of insects which are present in that particular region, and you can pass on that message to entomologists, and you can get a suggestion from them whether you need to go with a pesticide or whether you need to that particular insects which are recorded in your trap are negligible. So next one, timely usage of required amount of pesticides. Why? Because simply, I don't know about your country. In India, there is a procedure that if it's a month of February, simply spray pesticides. Why? Because so mangoes will be ripening. In that cases, the Bactrocera will arrive. That's why we will spray. So there might be some farms where there might be no pests are available, no harmful insects might be not available. So even in that scenario also, they are going to spray the pesticides. So such things can be avoided. Such things can, if you know, if the particular trap or the particular device is capable of identifying the count or the density of any insects which are present, then it will serve as an input. It will serve as an input for the farmer. So there is no need of simply spraying pesticides. So that's why if you simply use the more pesticides and fungicides, obviously it will harm the farmers. It will harm the consumers. So England is the #1 exporter of importer of mango fruits which are produced in India. Due to over usage of pesticides, our mangoes are not now, they are not imported to England, UK countries. Why? Because simply over usage of pesticides will harm the health of the consumers who's going to eat. So next, conservation of pollinators. For example, to destroy the pests, I'm going to spray the pesticides. It is not going to destroy only pests. Along with the pests, it's going to destroy the pollinators. Before using any particular chemical, you must know, right, what's the count of harmful insects? What's the count of useful insects present there? Okay, if the count is around 80-20, 80 harmful insects are present, 20 useful insects are present, okay, you make use of chemicals. If the count is around 20-80, for 20 harmful insects, you're going to kill 80 pollinators. Such things are happening. You can control such things. And cost effective. Cost effective in the sense, obviously, you're going to use less resources in the sense, less pesticides, less fertilizers. So that will in turn reduce the cost, and that will in turn increase the income of a farmer. less resources usage, and cost effective, and manual field monitoring is not required. Why? Because I'm going to design a device and the design will be embedded, the design will be placed in the form fields. So that will serve the purpose, that will do the task of entomologist. Is it required to bring entomologists to check the condition of any form field? It is required you guys to do the form visits? No, obviously it will reduce the cost and it will reduce the manual labors required for the exit, for the growth. So future research challenges. Which are the future research challenges of this particular computational entomology? The future research challenges is, so whatever that I have shown, I have done, I have applied machine learning algorithm, I have applied CNN, I have applied mobile net, teachable machine. Whatever I have shown, okay, that is on the data set. That is on readily available data set. Okay. I have not applied in field. So I don't know how accurate my device or my model will work, will classify or will identify the harmful insect or harmful useful pollinators when I implement this particular technique in field. Why? Because as a prototype, it's working fine. As a model in my device, it's classifying wonderfully with 94% accuracy. But I don't know how it's going to work. Why? Because it depends on these 4 parameters. One is, first one, insect behavior. How, I don't know how the insect is going to come to my device for to detect the image. Whether it's going to come in from the how the images are present in Google in the same manner the insects will be appearing in front of my camera. I don't know. Whether it's not a human being, right? So how we take selfie in the similar manner, insects will not come in front of camera and they will ask us to capture my image and classify. Okay, I don't know how the insect is going to behave. That's the one challenge we have for future research. Other one is presence and absence of sunlight. Why? Because there might be some conditions, even in the morning time itself, it will look like night due to absence of sunlight or due to presence of cloud. Okay, in all those scenarios, why? Because the presence of sunlight will show the image, insect image in the different manner. The absence of sunlight, the same insect will appear in the black. So how are you going to detect that? That's also one challenge. And there might be some scenarios where that particular device, that you're going to use for the classification or identification might have some fallen leaves and flowers. How are you going to ignore them? For example, just for your information, there are some insects which will look like a grass, which will look like fallen leaf, which will look like fallen flower. How are you going to identify them? That's also a challenge. So next, classification of intra-order species. Intra-order means same classes. For example, classifying a man and dog is an easiest task. Both will look in a different manner. How to classify whether this particular person is Indian or this particular person is from US? Okay, you can classify based on the color. How to classify whether this particular person is from UK and this particular person from US based on their external features? It is not that much easier. Why? Because both are fair in color and both are having black hairs and both are of 6 feet height. How are you going to classify? If the classification is happening between 2 different classes, fine. If the class, if you want to classify within the class, different species should be classified, means it's not at all that much easier to classify. Okay, so this will be the future or research challenges that can be approached, that can be addressed in this computational entomology. And please remember, computational entomology is a wonderful branch. Okay, it's having a huge scope nowadays. Why? Because everything has been automated. Not only this entomology, the whole agriculture process, but the term that we are going to use is precision agriculture, and whatever with to detection of various diseases that can be, that's also automated by using this by the involvement of this particular machine learning and deep learning technologies and artificial intelligence. Similarly, now the entomology is also automated. Entomology is also converted into computers by using this computational entomology. Okay, presently not that much work has been done in this domain, but in future, the lot of work will happen in this domain. So that will address, I guess that will address these issues. So the students who are listening to this talk, for them, I'm giving a one suggestion, that is, so without bees, without honeybee or without pollinators, we cannot have our food. It's our duty to conserve them. It's our duty to save them. Okay, for that, we have wonderful technologies which are now available in our computer science, such as Internet of Things, cloud, artificial intelligence, image processing, deep learning, neural networks. Lot of technologies are available. So if those technologies are not applicable to save us or to save the pollinators which are helping us to have food meals, so what's the use of that technology? So now it's our role to apply those technologies, and it's our role to help our farmers. It's our role to save the pollinators to have the food that we are having right now. Okay. Thank you. So any questions, sir?
Okay, first question we have Mrs. Rajesh ready? Oh, just a moment, please. Yeah.
Hello, Miss Novita.
Yeah.
Miss Novita. I'm actually a miss, not Miss.
Sorry, what? Can you repeat?
You can call me as Miss, not Mrs. I'm still a student. Mrs. is for married woman, actually. Oh God.
Okay.
Okay. Hello, Professor Nithin. Good afternoon. Yeah.
Good afternoon.
I would like to ask some questions. You said that it is a prototype. It's not. It hasn't been implemented yet. So it's that mean that it's not really distributed in India. It's not.
Yes, it's not implemented in India at.
Hello.
Hello.
Yeah, it hasn't been implemented in India.
Yes, it is not implemented in India. Still, we are using traps, just traps. So where we will use some oily sprays to attract the.
Okay.
Yes.
What stop you to implement it in field?
So,
You said that
yes,
it is a prototype. You haven't implemented it in field.
Yes.
What stopped you actually?
It's not at stop. It's in progress.
Okay.
It's
But
in
the accuracy
progress.
is already in 94% as a prototype. So
Yes.
you can proceed actually, sir.
Yes, I can proceed, Rajeshwari.
Yeah.
Just now I have fixed that the deep learning models will work fine compared to machine learning models with respect to insect identification and classification. So now I need to devise the trap. So these are the problems that I will face. One is how the insect is going to behave. I don't know. The presence or absence of sunlight, I need to consider this. And the fallen leaves and flowers, even they will look like a flies. Some flies look in the similar manner, right? So, and how to classify the insects which will come under the same class. Why? Because just the house fly and the harmful Bacteria will look in the same manner. The physical appearance is same. Why? Because both will come under the class Diptera. Houseflies are not harmful. They will not harm any crops. So such challenges are there. So it's still in progress. I have not stopped implementing it. Just okay. I have fixed which feature to consider. I have fixed which deep learning models to consider. So I'm in that stage. Now I need to design a device so to help our farmers.
Okay. Sir, is it possible to implement it in rural areas? Because as you said
Yes.
that it is needs network, internet actually
Yes.
for processing. So as we know that in rural area, the network is not distributed well. So
Yes, please observe. So one thing nowadays, so peoples can live without food.
Yeah.
It's not possible to live without internet. Correct me
Yeah,
if
but
I'm wrong. Even in the rural regions, almost all, except the peoples who have crossed 70 years or 80 years old, they don't know how to use the internet or the mobile devices. Even the old grandfather, grandmother who are of 60 years ages, they are using internet. Correct me if I'm wrong. Even in the
yeah, they
rural
are
regions,
using, but it is
the
for
two,
simple tasks, sir. Simple tasks, not for this. I think it is quite difficult.
That too, once after the evolvement of Geo in India, everyone is having the connectivity to internet. That too, 4G internet connection is there.
Okay. Okay, so it is possible.
Yes, possible.
But
so please observe Rajeshwari. Rajeshwari. So now I have conducted this session for your classmates, I guess. I don't know the actual strength. Okay.
Okay.
So I am here to convey about the computational entomology for your whole classmates. But I don't know how many of you understand. Even if there is only 2 candidates who have understood what I have conveyed, that's more than enough for me. That has served the purpose, right?
Okay.
I don't know how much, up to what extent it's going to help the Indian farmers. So if it helps only 10%, okay, I am happy with the 10%.
Sir, and one thing, why you said that about, what is it? Environmental feature is not really important as above, like characters and
why environment, characteristics and morphological feature? So Rajeshwari, for example, characteristic and morphological feature. Jeff, you consider those two. So how you are speaking English, how you walk, how you move, such things are your characteristic feature. Okay, morphological means, so how you look, so what's your hair color, what's your color, like means morphology based on the texture. So those things are morphological features. Those two features will play an important role while recognizing any particular insect. So environmental parameter is an additional thing. So that can be correlated. So if a person is present in this particular, for example, if you, I don't know if you are from which state in India. Okay, so South Indians are little darker compared to North Indians. Correct me if I'm wrong.
I know.
Why? Because we come under the tropical line that passes, so that the sun rays will fall on us, who are present in South India. So the North Indians are in safe zone. That's why they are fair. Similarly, it's not a single parameter. Why? Because even the dark peoples are present in North India also. Okay, just it's an added advantage, environmental feature, but it's not final. So you cannot use solely environmental feature to perform classification or recognition.
Okay. I'm actually from South and Tamil, but I was born and stay in Indonesia. So.
Yes. So I can. That's why I told you that. So I can easily recognize you are from our South India. So we are from Karnataka. You are neighbors.
Okay. So what is next? Is there any? So, sir, in computational entomology, is it only for identify, not only for predict which method we should use? Should we use pesticide or not?
So you can predict which pesticides or which fungicides you can be used, and you can predict based on what is prediction means. It's nothing but based on the past experience, you can predict the next one. Correct me if I'm wrong. Based on the past experience, you're going to predict the next future. That's what we call prediction. We have a lot of prediction algorithm. So once you are done with the classification, once you run that particular model for a year, so you will come to know in which month, in which season, so the pesticides will be more. in which month, in which season the pollinators will be more. So from next year onwards, you can use that prediction. So early to implement it, so prediction is not possible. Why? Because there is no implementation at all. How you can predict?
Yeah.
So I need to perform the run of this model for a year. I need to record the result. So that result will serve the pest. I have shown a last slide where insect pest model can be developed.
Yeah. Yeah.
Application insect pest model based on the experience that we are going to get. So we can develop that prediction model.
Okay. Okay. So, sir, please implement it in field soon. I would like to know more.
So within 1.5 years, I'm going to implement it in India. Why? Because this is my PhD work. So it's in progress.
Because India is our largest agricultural country, right?
Yes. So my major concern with respect to this, why I have chosen this topic is, so India is the major producer of mango. So out of 100%, 70% of mango crop will be produced by India. But so mango crop will be produced in the month of March and April. So in the month of February and March, our farmers is going to spray huge pesticides,
which is harmful for us.
Yes, it's harmful. It is harmful for food. Along with that, it will destroy pollinators.
Yeah, it's true.
So to avoid that, I'm planning to develop a model. I don't know up to what extent it will be useful for the farmers, but I will develop a model.
Actually, it is a new field for me, sir. So yesterday I'm looking for this material and I got it from one of your website, Research Gates, maybe.
Yes,
I download it. Yeah, I download it. Okay, thank you for answering, sir. I think it is my questions only.
Thank you, Rajesh.
Kak Novita, I'm done.
Okay, thank you for Miss Rajesh. Right. Okay, I guess no one else asking. Can I continue the closing session, Prof?
Okay.
Okay. Can take a picture together.
Okay.
Yeah. For Aska, you can take.
Okay, let me take some screenshot. 1, 2, 3, and please open your can if you are, because I want to take some screenshot. Okay, 1, 2, 3, and cheese.
Okay, is it done?
No, one more.
More?
Okay. 1, 2, 3, and cheese. Okay, thank you.
Okay, thank you for Professor Nithin Kumar. I'm sorry, Nithin Kumar Algebraic. Okay, thank you for sharing your knowledge with us. It's a very beneficial for us. Thank you for joining this event. Thank you so much for Professor. Thank you.
Thank you, ma'am.